Hello everyone, I am Amit Kumar, Assistant Professor in IT Department. Today I am going to give on CPU scheduling. Okay, so what is CPU scheduling? CPU scheduling is a method in the operating system where the CPU synchronization is done here. So for the CPU scheduling is a process that allow one process to use the CPU while another process is delayed in standby due to unavailability of any resources such as input, output, etc., thus making full use of the CPU. It means in the CPU scheduling, we are using the CPU for they are not being the rest position in the CPU. So for the CPU time, we are using the process are coming into the CPU time and process are requesting for that one k I have to give I have taken some input and you have to give some output. So where I have to go. So without any delay, the CPU has to do all the things. Okay, the purpose of CPU scheduling is maximizing CPU utilization. Okay, how much we can use the CPU, fair allocation of CPU. Okay, what are the allocations of CPU would be done from that side, maximum throughput, how much work is going on in this one, minimum turnaround time, minimum waiting time, and minimum response time. These three are the important parts of the algorithms for the CPU. But what is turnaround time and what is waiting time and what are the response time, we will go in the further slide. The terminologies and the CPU schedulings are in the algorithms are these are the you can say that these are the most important terminologies used in the CPU scheduling algorithms. So first is arrival time. Arrival time in the time in which the process arrives in the ready queue. There are there are two queues over here. We are making a Gantt chart and then the ready queue. In ready queue, which process is coming from which process is coming to the next, and it will store other process that which process is coming into the next part. Arrival time is that one. Completion time, time at which process completes its execution. It means the process which is going to be execute completely, that is known as the completion time of that process. Burst time, time required for the process for CPU execution, the process of execution time for the process, that is known as the burst time. Turnaround time, time difference between the completion time and the arrival time, means CT minus AT. CT minus AT. As I have told you in the previous slide, I will explain the turnaround time in the next further slide. This is the turnaround time for the further slide for that one. And the waiting time, the difference between turnaround time and the burst time. Okay, turnaround time and minus burst time. This is the waiting time. Means the time difference between the around turnaround time and the burst time means what is the waiting time of the process. The process is waiting in which queue and how much time it is going to be done. So there are types of the CPU schedulings there are mainly two types of scheduling methods, preemptive and non-preemptive. Preemptive means preemptive scheduling is used when a process switches from running state to ready state or from the waiting state to the ready state. Okay, means preemptive is scheduling is used when the process switches from running state to ready state. Means the switch from the process is working on the CPU, and if another process is coming into the priority base, then it is a preemptive type. So this is the waiting state. And non-preemptive scheduling. Non-preemptive scheduling is used when a process terminates or when a process switches from running state to waiting state. It means non-preemptive means the process is going switches from running state to waiting state. Now, there are various types of CPU scheduling algorithms. The first is first come first serve. First come first serve scheduling algorithm states that the process that requests the CPU first is allocated the CPU first, and it is implemented by the FIFO queue. First come first in first out. This works. Okay, FIFO, first come first out, FCFS. Okay, so this works as a FIFO, means the process which has came first, it will execute first, and after that this will be the follow on. And the characteristics of FCFS is FCFS support non-preemptive and preemptive CPU scheduling algorithms. Tasks are always executed on the first come first serve concept. FCFS is easy to implement and use, and this algorithm is not much efficient in performance. Okay, and the waiting time is quite high. So because the process is coming from one by one, so it will give the quite high time of the waiting time. So advantage of FCFS is it is easy to implement and it is a first come first serve method. Disadvantage, it suffers from the conway effect and the average waiting time is too much higher than the other algorithms, and FCFS has the very simple and easy to implement and not much efficient. So considering we are going for the algorithms for the solving the numericals, so first first we are having the first come first serve, and there are 5 processes whose arrival time and bus time are given below. So this is the process ID, P1, P2, P3, P4, P5, and arrival time is 35044, and the bus time is 4321, and we have to find the completion time, turnaround time, and waiting time. So the turnaround time is, as we have read in this one. Okay, what is the turnaround time? Completion time minus arrival time. So we will write here completion time minus arrival time, CT minus AT. Okay, turnaround time. And waiting time is TAT minus BT. Okay, listen from here, TAT minus BT. Okay, BT. Now we are going to be for the solving the method. There is a response time also we are going to be do for the response time, but right now I'm not finding the response time, but we have the 3 criteria to find the all the things. So we have the ready queue or Gantt chart. So we have to the Gantt chart is important to know from where it is going to be processing. So the CPU arrive at a 0. So which process is arriving at a 0? P3. So P3 arrive at a 0, and P3 completes at a 2. Okay, it will be 0 means 2. Okay, so within 2, this is a Gantt chart, and if, as I have told you, the ready queue. So the ready queue will be perform as like this. P3 will come at the process, and P3 will run at 2. But when 2 is coming, which process is within the arrival time? No one. So next process will come in the third part. So 2 to 3, there is a CPU idle. Okay, CPU idle means CPU is not working, is this one. 3 at 3, P1 has arrived. So P1 has the boss time of 4. 3 or 4, 7. So on 7, all the process have arrived here. So after 3, the 4 is coming P5. So P5 is having 4 to 0, 3 to 0, 10. Okay, now these two are having the same arrival time, but this has came first. So P2 will run first. P2 have 3, 13, and then P4 1, 0, 0. Okay, so 13 and 1, 14. And if we will check, this will be total 14. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. So 13 and 1 is that is CPU. CPU should one time CPU is idle. So this is the 14 part. So the completion time of P1 is 7. Completion time of P2 is 13. Completion time of P3 is 2. Completion time of P4 is 14. Completion time of P5 is 10. Okay. Now TAT, CT minus AT. CT 7 minus 3, 4. 13 minus 5, 8. 2 minus 0, 2. 14 minus 5, 9. And 10 minus 4, 6. Okay. The waiting time is TAT minus BT. 4 minus 4, 4 minus 4, 0. 8 minus 3, 5. 2 minus 2, 0. 9 minus 1, 8. And 6 minus 3, 3. Now we will add this one, and after adding, we have to divide by 5. So this will be the average TAT is equals to 4 plus 8 plus 2 plus 9 plus 6 divided by 5. And average waiting time is 0 plus 5 plus 0 plus 8 plus 3 divided by 5. This is the average TAT, and this is the average waiting time of the first come first serve algorithms. Okay, so this would be the first come first serve, and the ready queue, as I have told you, P3, and this 3 has came, and the process has been 3 has been come, and P1, then P5, then P2, then P4. This is the ready queue where it is going to be work. Okay, now Shortest job first. Shortest job first is the scheduling process that selects the waiting process with the smallest execution time to execute next. This scheduling method may or may not be preemptive, significantly reduce the average waiting time for other process, and waitings would be executed. The full form of SGF is shortest job first, means the burst time, the process have the lowest burst time, it will execute first. So the advantage of shortest job first is the reduce the average waiting time, thus it is better than the first come first of scheduling algorithm, and SGF is generally used for long term scheduling. Disadvantage, one of the demerit is starvation, and many times it becomes the complication to predict the length of the upcoming CPU request. So this is the next numerical for the SJF. So I am taking the ready queue and the Gantt chart of this one, and I am going to be solved for this one. So the Gantt chart and the ready queue. So again I have to find the completion time, TAT, and waiting time. So waiting time is TAT minus BT, and this is CT minus AT. Okay, as I know from the previous slide. Now, and this is the Gantt chart. From 0 it is going to start, and the ready queue also is going to be start from 0. So for 0, P3 has been arrived. Okay, P3 has been arrived, and P3 has the lowest burst time right now, but the lowest burst time is P4, but P3 has arrived first, so P3 will execute whole 2. So P3 will execute 2 times, and after 2 there is no arrival time for the any process. So next arrival time is in the 2, no process has been arrived, so we can't see the burst time. So next we will CPU is idle for 3, and on 3 P1 has been arrived. P1 it will be execute at 4 times, that will be 7, and in 7 all the process has been arrived, and for that 2 to 3 has been CPU has been idle, and P1 has been come, and in the 7th part, if the 7th part has been run, then it will be go for the after P1. I am taking the non-preemptive. Okay, after that one, whose burst time 1, then P1, P4, and P4, then these two are matched, so we will take the first arrival time, so P5, then P2. Okay, this would be the work of this is the ready queue. So after P1 7, then P4 will be execute, then P4 I will be execute one time 8, then P4, after P4 P5 will be execute 3, 11, and P5, then P2 3. Okay, this is the Gantt chart. Now completion time of P1 is 7, P2 is 14, P3 is 2, P4 is 8, and P5 is 11. Okay, so CT minus 80, TAT, CT minus 80, 7 minus 3, 4, 14 minus 5, 9, 2 minus 0, 2, 8 minus 5, 3, 11 minus 4, 7. Okay, waiting time. So waiting time TAT minus burst time. 4 minus 4, 0, 9 minus 3, 6, 2 minus 2, 0, 3 minus 1, 2, 7 minus 3, 4. Okay, so the average TAT is equals to 4 plus 9 plus 2 plus 3 plus 7 if by 5, and average waiting time is equals to 0 plus 6 plus 2, 0 plus 2 plus 4 by 5. So if you will check from the FCFS and this SJF, the average waiting time and average TAT is low from the previous one. Okay, next SRTF. The work I have done, it is a non-primitive, but in the SRTF is the preemptive version of SJF. So SRTF is preemptive version of the SJF, and it is where the processors is allocated to the job closest to the completion. These algorithms require advanced concepts of the knowledge of CPU time required to process the job in the interactive system, and hence it can't be implemented there. But in a batch system, there is a desirable to preference for the job. SRT's algorithm is going to be used. Means this is the primitive version of SGF. Only this I know, and how I have to do in the numerical, I will solve the SRTF. The advantage of SRTF is SRTF algorithm makes the processing of the jobs faster than SJF algorithm, shortest job first, and gives the overloaded charges are not counted. Allow for easier management of library updation or the replacement. And disadvantage is that is the context switch is done a lot more than SRTF than the SJF, and consumes CPU valuable time for the processing, and it's added the processing time and the diminished its advantage for the fast processing. So this is the numerical again for the SRTF. I have took the same numerical for this one. So I have to find the completion time, TAT, and waiting time for this one. But first I will take, this is the preemptive version of SRT. So we are taking the ready queue and Gantt chart. From 0, the process has been arrived P3. So P3 has been arrived for this 0, and it will run for one time. Okay, at 1 anyone has been arrived? No. Again P3 will run. P3 has just 2, so it should be the 0. For 2 anyone has been arrived? No. So next will be 3, and it will be CPU idle. Okay, in the 3 P1 has been arrived, P1 has been arrived, 4, P1 has 3. Now we will check at 4 anyone has arrived? Yeah, P5 also has been arrived. Okay, and the burst time of both are the same, but P1 will execute first. So P1 arrived first, so P1 has the 5, and P1 has executed 2. So on 5, who has been arrived? P2 also arrived, and P4 has been arrived. So first the P4 will be run, because P4 will go for the lowest. Okay, so 0 P4 has been run to the 6. P4 has been completed. Now on 6 all the processes. Now who has the lowest? P1. Okay, so P1 will execute 2 times 8. Okay, P1 has been 0, and P2 and P5. So P2 have arrived first, so P2 will run first, and this is the 3 times, so 0, and then P5, that would be the 14, 0. Okay, so the completion time, if you will match, this is the primitive versions of the SRT. So the P5 has the arrival time has the 14, P2 has the 11, P1 has the 8, P4 has the 6, and P3 has the 2. Okay, this is the completion time. So TAT means completion time minus arrival time. 8 minus 3, 5, 11 minus 5, 6, 2 minus 0, 2, 3 minus 6 minus 5, 1, and 14 minus 4, 10. And the waiting time of this means TAT minus burst time. Okay, 5 minus 4, 1, 6 minus 3, 3, 2 minus 2, 0, 1 minus 1, 0, and 10 minus 3, 7. This is the average. So we will find the average TAT is equals to 5 plus 6 plus 2 plus 1 plus 10 divided by 5, and average waiting time is should be 1 plus 3 plus 0 plus 0 plus 7 by 2. If you will check, so 6 5 11 12 13 14 24 upon 5, and this would be this something 11 upon 2. Okay, this is the average TAT, and this is the average waiting time of the SRTF of same numerical. If you will check, the time difference has changed. Okay, next, priority scheduling. Preemptive priority CPU scheduling algorithm is a preemptive method of CPU scheduling algorithms that works based on the priority of the process. In this algorithm, the editor set the functions to be the important, meaning that the most important process must be done first. In the case of any conflict, that is where there is a more than one process with equal value, then the most important CPU planning algorithm works on the basis of the first come first serve algorithm. As the what can I editor sets the priority, then we have to work on that one. So priority having the priority have the path, and we have to take as a basis of the first come first serve. The advantage that average waiting time is less than FCFS and it is a less complex, and disadvantage of this one is the starvation problem, and this is the problem in which we have the wait for the longer time for the get to schedule the CPU. So as this is the numerical for this one, and process has been given, and the arrival time and the burst time and the priority has been set. So the highest priority means the lowest number is the highest priority and the highest value is the lowest priority. So it has been given. So we have to find the completion time, turnaround time, and the waiting time. Okay. Now we have to check all the things by the priority scheduling. So we are going for the Gantt chart. From 0, the process has been arrived for the P3. Okay, P3 has the highest priority. It will be work for this, and this will be run as a 2 part. So on arrival of 2, there is no arrival, so there is a CPU idle. Then it will be the 3. On 3, who has been arrived? P1, and anyone has been arrived? No, and the priority is P1 has the priority. So P1 will be run, okay, 4 times. 4 or 3, 7. On 7, all the process has been arrived. Okay, all the process. Now we will check the priority. So third, this P5, P4 will be run as first because 8, because its priority is the high. Then fourth, okay, fourth one is P2 has been arrived for the 3 part. Then P5, 14. Okay, so this is the Gantt chart of this algo. By this algo, so the completion time of P5 is 14, P2 is 11, P4 is 8, P1 is 7, and P3 is 2. So that would be the CT minus 80. Okay, that would be the CT minus 80. 7 minus 3, 4, 11 minus 5, 6, 2 minus 0, 2, 8 minus 5, 3, and 14 minus 4, 10. And waiting time TAT minus BT. Okay, so 4 minus 4, 0, 6 minus 3, 3, 2 minus 2, 0, 3 minus 1, 2, 10 minus 3, 7. So average TAT is 4 plus 6 plus 2 plus 3 plus 10 by 5. That is, I'm calculating it, and average waiting time is should be 0 plus 3 plus 0 plus 2 plus 7 by 5. So it would be the 5 units, and it would be the 12 upon 5. So it would be the 5 to the 10.520 2.4 units. Okay, so we are calculating like this for the average time or waiting time. This would be the all the Gantt chart and CPU scheduling are working like this. There are 3 words I haven't explained here. That is a starvation problem. Okay, what is a starvation problem? If any process is waiting for the CPU and the other priority based process is not leaving the CPU, so the lowest priority is waiting on that one, and if it is continue waiting on this one, this would become into the starvation, and it come under the deadlock problem. Deadlock having the 4 problems, having mutual exclusion. If we don't have the mutual exclusion, the deadlock will happen. Then hold and wait, and the starvation comes again comes under the hold and wait conditions. No preemptions, and fourth one is circular wait. This is the starvation coming from the deadlock conditions. So starvation is this one, and the Gantt chart we are preparing, and there is a use of this one. If we are finding with the codes, so CPU idle is not going to be idle for this time, because when the CPU is idle, the another process is working in the CPU. But for this algorithm, CPU is going to be idle because this process has not been arrived for this algorithm. Okay, and the switching, context switching, as I have told you, there the word here is context switching. Context switching means if one process is from one if the process one process is in running ready queue and another process is in the waiting phase, and if the process is coming from ready to run, so it is switching the process in the CPU. So this is known as the context switching. So these are the conditions where I have done. So we will do in the next lecture for the others CPU scheduling algorithms, deadlocks, and other concepts of the operating systems. Thank you so much.